All right, so good morning, everyone. Thank you again for joining us. My name is Sarah Husky with 3C Ren. I've started recording this course and it will be posted on our on-demand page. Today we have Nick Brown with Build Smart Group and Bobby Hahn from Pacific Systems Group with us to talk about lessons learned from installing heat pumps. Before we get going though, I just have a few slides to run through. So we just ask that everyone make sure that they're on mute throughout the course. If you'd like to ask a question, please raise your hand and we will call on you to unmute yourself. We also encourage questions in the chat. I'll be monitoring that, and so we can get those questions answered. I also ask that you rename your display, your profile name. It just helps us with reporting and keeping track of attendance. Okay, next slide. So a few words about us for those of you that might be new. We are the Tri-County Regional Energy Network, also known as 3C Ren. We are a collaborative partnership between San Luis Obispo, Santa Barbara, and Ventura counties, working to improve energy efficiency in our region by offering free programs and services for building professionals and households. We currently offer 3 programs. And next slide. The first of which is the Energy Code Connect program, which serves building professionals by offering Title 24 support for everyone from plans examiners and inspectors to architects and contractors. Within this program, we also offer our Energy Code Coach service, which is an over-the-phone, online, and in-the-field support for Title 24 questions for both residential and non-residential projects. And I just want to call out that our phone number recently changed. It's listed here on the slide, but our existing phone numbers you can still find us. Next slide. Another program we have is our building performance training, which serves building professionals such as architects, engineers, contractors, and real estate professionals by offering technical and soft skill training related to building science principles, high performance buildings, marketing, and communication techniques. And then we have our home energy savings program, which incentivizes contractors and helps residents save money and make their homes healthier with energy efficient upgrades through incentives and rebates. You may see a few 3C Ren staff members on the training today. If you see anyone with this background, feel free to chat with them. And with that, I'll pass things over to Nick and Bobby.
Thank you, Sarah. Good morning, Bobby. How are you?
I'm doing great, Nick. Good to be with you again.
You too. Yeah, this is fun. First time we've taught this class for 3C Ren. Heat pumps, but really where the rubber meets the road, and drawing especially, Bobby, on your experience selling these all over the state.
Yeah, it's been a pretty steady upward curve, as we'll see in a little while here in one of the slides, Nick. So it's been very good.
Yeah. And let's do introductions. I run a small energy consultancy out of Long Beach, just south of your 3C Ren territory. I'm a KBEX CEA, which means I know the energy code and how to model buildings. And I teach a number of classes like this, in addition to my Title 24 compliance work, like the Energy Code ACE class for residential architects, all electric residential buildings for SCE, courses like that. And I love teaching classes because it really allows me to interact more with people out there doing the stuff and amplify the impact of our work. Also doing a California Energy Commission research project on HVAC systems using phase change materials as thermal storage systems, which is really cool. And there you see my email. How about you, Bobby?
Well, yeah, really, it's close to 30 years ago. Just getting out of school, I entered into the world of HVAC. I got a crash course in Texas after my college, and then went to Japan. And since then, I haven't moved. I started in ductless mini splits, and that graduated to VRF and DX systems, chilled water systems, all kinds of HVAC, mostly on the DX side. I am also a member of KBEC, but I am not a certified analyst like Nick. I am previously on the board of IHACI, which is the Institute of Heating and Air Conditioning Industries, as well as ASHRAE, ACA, and MANA, which is a rep organization. So quite a few years in this industry. Look forward to talking to you today, and appreciate you spending the morning with Nick and I. So Nick, I'm going to go ahead and hand this boat back over to you, and then we'll get started.
Well, awesome. And it sure seems like the world's coming to you, Bobby. When you got into heat pumps, you chose right.
It chose me, really, Nick. I mean, I didn't know where I was going in this HVAC world, but it kind of came all to fruition. And when I started, almost 99.9% of the country did not know what a ductless mini split was.
Right.
But boy, have things changed now. So
yeah.
Here we are.
All right. Well, we can't be together in person today, but we use Slido to try to make the experience a little closer to that. So Slido we like because you don't have to sign up for an account or anything. Just point your cell phone at this QR code. It'll link you to our set of poll questions. And we've got like a dozen of them scattered throughout the slide deck today, just to check in and hear your feedback on how things are going, get your questions out in as engaging a way as possible.
Yes, I urge everybody to please put this Slido presentation makes it much more enjoyable, much more feedback. So just run your camera across this QR code, and is a really good way to gauge where everybody's at in the presentation.
Yeah, you can also do it through your browser at slido.com with that code, HP Lessons. Well, so with that, let's start. Let's get to know you. Tell us what you do for a living, what brings you to the class, what you want to make sure we cover. And this will make sure you've got the window up and rolling before we get too deep.
Oh. I know a lot of you are just downloading the QR code now. Okay, I think I possibly could be one of my staff. So
and I see Jurgen's comment in the chat that he's got some heat pump systems in his house and trying to fine tune them.
Great. Yes, in Ventura County.
Okay.
So he's pretty close to this, where we're going to be doing some examples.
And shout out to Ted from Quit Carbon. Quit Carbon's a group I engaged with about a year ago, and they really work with homeowners to develop a plan to remove fossil fuels from their homes. I love the Quit Carbon concept, as if you're quitting smoking or something. So highly recommend their free service to try to develop a plan for your own home. All right, we've got some industry people here for sure. All right, well, hopefully you are all able to get on 140 projects. Okay. Hopefully you're all able to get on Slido. And when we have something to say, you'll say it. Well, we set this up as a class really for the industry to consider all the reasons to add heat pumps to what you do. Because many of you in the HVAC industry are as busy as you could possibly be. You know, why should I bother stopping, rewinding and press playing on gas electric split systems? But this content's so relevant to architects and others in the industry too. So I think you'll all find some good takeaways here. And then Bobby's going to cover in basic terms how heat pumps function and how they differ from the way we've typically done things. And we'll spend most of our time diving into these key installation hurdles and lessons learned, including ductwork, air filtration, ducted, ductless options, cold weather performance, sizing. These were the themes that came up time and time again in our focus group interviews as reasons why heat pumps haven't been adopted more. So let's start with the business proposition, the value case for you to engage more with heat pumps. First of all, this is the national AHRI chart of heat pump sales growth. You can see it's considerably ramping up. But I like this next chart even more. This came from the Heat Pump Forum that the California Energy Commission hosted earlier this year. I went to the one in Newport Beach, and look at that. The market share of heat pumps in single family new construction almost doubled in 2 years.
That's it. That's from 30% to almost 60% is unbelievable growth of
Yeah,
any sector, really,
right.
of any industry. But to go that high in 2 years is really incredible.
And I think the data is very believable because it comes from the CF1R forms that we submit for Title 24 compliance to the HERS registry. So
Hmm.
really perfect way to measure the change in the market. Are you seeing that, Bobby? Does your experience back that up, that home builders are adopting heat pumps in higher numbers than before?
Yeah, in California, we have a new set of codes. We're going by SEER 2, and most manufacturers are already set for SEER 2. And it, as fast as they can build them, they're selling them. So that's what we're seeing.
Okay. And we wanted to start up front. We used to have this slide, you know, when we taught this class 3 years ago and heat pumps were a little fringier, only 30% market share. We used to have this back towards the end, but I moved it up front today because I think many of you may be here because of these reasons. And that is, we need to remove carbon from our buildings in California, residential, commercial. And it's not enough to just slap solar panels on a building. We need to remove the systems that consume fossil fuels. And the fact is, our climate statewide is ideal for heat pumps. Now, Sierra Nevada installations are going to be a little different than the rest of the state, maybe, but there's so much heat in the ambient air that heat pumps can harvest. We're in a great spot. And they're the way to take fossil fuel out of space conditioning, right? Most homes have typically had an electric air conditioner for cooling and a gas furnace for heating of some sort. Heat pumps do both functions with electricity with no need for the gas line. We find also that our legislature has embraced greenhouse gas reduction goals fully. And it's all electric homes that have roughly half the greenhouse gas emissions of mixed fuel homes. This was something I was not aware of when I started in the business, and I remodeled my own home with a gas furnace and a gas tankless water heater, thinking I was making a wise decision. But now that we know our grid is going to 100% clean, emission-free electricity by 2045, it makes no sense to continue to build or remodel existing homes with fossil fuel systems in them that can't benefit from that greening of the grid. We've also got REACH codes in multiple jurisdictions, and maybe Sarah, you could summarize that for us in your conclusion. What parts of the Tri-County area already have these electric REACH codes? But you can't get to all electric without heat pumps. So if you're working in those jurisdictions, you're going to want to know more about heat pumps. And some of the ones we know of, San Luis Obispo, Santa Barbara, LA just passed one, although it's not in 3C REN territory. We've also got prescriptive standards that changed in the 2022 code, which now we're 8 months into the 2022 code. And Climate Zone 4 is some of your territory, Sarah, and 3C REN territory, but 3, San Francisco, 13 and 14, a lot of that Central Valley into Lancaster in Southern California. And from what we hear, heat pumps are likely to be prescriptive standard just about statewide in the next code cycle. So here are some of the goals that our legislature and executive branch have committed us to in California. Greenhouse gas reduction economy-wide, in the building sector in particular. Notice SB 100, that 100% carbon-free electricity by 2045. Really important that the legislature did that in 2018 so we could all be focused on the long term. And money like SB 1477, Tech and Build for incentives, not to mention the federal work. The IRA brings even more incentives to electrification of space conditioning. So there's just every reason to embrace heat pumps.
Hey, Nick, I have a question for the last slide, if you don't mind going back
Yeah,
one. The carb slide, no gas furnace or water heater sales by 2030. I think that was added. Is that including replacement, or is that just new construction?
yeah, that's no sales in the state by
Wow.
2030.
Okay. That's not far off.
Yeah,
So
that's right.
yeah, if you put one in now, it's going to be obsolete in a couple of years down the road.
Yeah,
So,
it's hard to
okay.
keep up, isn't it, Bobby? Because we tend to focus on the California Energy Commission and Title 24, but we've got the Building Standards Commission and their Cal Green Code, which does important things in various areas. We've got CARB making their own policies, the Air Resources Board. We've got the various AQMD, the Air Quality Management Districts. So there's all these different levers that advance us on heat pumps, advance us on greenhouse gas reduction, and it's hard to keep up, not to
Yeah,
mention the federal level.
in 3 years, this slide really changed. It's
Yeah,
getting pretty full. Okay, thank you, Nick.
right. And here are some of those REACH code jurisdictions. Most of them originally passed their REACH codes in the last code cycle, 2019. But new additions include LA, Santa Barbara, Encinitas, Solana Beach, San Diego County getting in on the act. I mentioned heat pumps and heat pump water heaters likely to be prescriptive standard in the 2025 Energy Code. CEC just had a stakeholder meeting on that. And then on the other side of things, Berkeley had a REACH code that banned gas in new construction, and their REACH code was put on hold after legal challenges, which we all kind of took a breath and said, what the what? So there's still uncertainty in this area, but the clear signal is this is the way we're headed towards heat pumps. So Bobby, this is you.
Okay, thanks, Nick. Did you want to take some time to go through the chat, or should we hold off on that until after maybe there's a couple Slidos?
Sure, did you see anything we need to address?
Yeah, well, let's see. Well, I'm sure it sounds like we have a good audience with Quit Carbon now. We have 140 projects. This is one I didn't totally understand, right, Jurgen? The current fad of tankless cuts off positive paths towards utilizing sun and means of storing energy. In other words,
I think he might be
solar.
talking about water heating. And
Yes, I think the
yeah,
tankless path, which now we have heat pump water heaters in place.
yeah,
Agree, Red?
let's put that in the parking lot for the end if we have some time to talk about water heating.
Sure. Okay. So thank you, Nick. So goal number 2 is to understand heat pumps. This is Bobby Hahn. How heat pumps function and the advantages of heat pumps have over traditional gas and electric split systems. And we'll compare the different systems. We have up to 4 different systems we're going to compare to in just a little bit. We do have a video that we wanted to take a few minutes to share with you. It goes through the reverse cycle and the reversing valve of a heat pump, and I think it's very important that everybody has a good understanding of just how these work. So why don't we go ahead and run through that video, Nick?
Yeah, I forgot to hit the share sound button, so I'm just redoing it.
Okay.
Seeing that okay?
I see it great.
All right, let's do it.
In the past, conventional electric heat pump systems were known for their poor efficiency and performance in cold weather temperatures. Today, advancements in modern variable speed heat pump and zoning technology gives everyone in the home year-round comfort, even in sub-zero temperatures. Here's how they work. Ultra-efficient variable speed heat pump systems consist of an indoor air handling unit and an outdoor condensing unit. The units are connected via 2 refrigerant lines. Working as a system, the units efficiently transfer the desired cooling or heating energy to each personalized comfort zone. In summer, air conditioning is produced when heat energy from inside a home is absorbed by the system's refrigerant and transferred to the outdoor air. In winter, the refrigerant cycle is reversed and the system extracts heat from the outdoor air and transfers it inside to heat the home. When compared to fossil fuel burning systems, modern variable speed heat pumps provide exceptional heating performance while being a greener, more environmentally friendly option. To achieve this, variable speed inverter compressors use up to 40% less energy than past conventional systems by modifying the compressor speed up or down as needed in order to maintain consistent, comfortable indoor temperatures, a feature conventional systems simply do not have. As an added benefit, some systems allow a single outdoor unit to control up to 8 indoor units for added comfort, efficiency, and styles within a home. Ductless indoor units circulate and filter the air already in your home, resulting in improved air quality with whisper-quiet operation. Today's revolutionary inverter compressor technology is an impressive advancement in residential heating and cooling. These smart systems regulate energy consumption, using only the precise amount of energy needed to keep a home comfortable, saving the homeowner money while reducing our carbon footprint.
And Bobby, I failed to plug in the video with the logos scrubbed out. I apologize.
That's okay. It's no problem at all. Okay, so thanks for the video, Nick. And just how heat pumps work. This is almost the same video slide from the video that you just had seen. And how heat pumps work, if you take a look on the left-hand side, this is the summer season. This is the season we're in right now, and it's been a brutal summer all across the country. And during heat pump operation, we're expelling the heat from the space, thus cooling down the space. And that heat in the condensing unit on the bottom right-hand of the left-hand picture is dispelling the heat energy to the atmosphere. It shows the outdoor unit connected with refrigerant lines to the indoor unit. You see the red and blue lines. And the penetration, if you're wondering, what does it take to enter into the house? The penetration for both lines being insulated is only about the size of a tennis ball. So if you can imagine, those pipes can fit through a penetration of about the size of a tennis ball and connect both sides via flare nut fitting, and then you have a heat pump. On the right-hand side, you're going to have winter operation, and this is all there is to it is utilizing a reversing valve. It's just reversing the refrigerant. So it's harvesting the ambient heat in the air and pumping that heat into the space, just using the exact same system, again, utilizing a heat pump. So pretty much this video, this slide, and the last video are simplistically how heat pumps work. So if there's any questions, please put them in the chat. Some advantages, heat pump advantages versus standard gas electric split systems. First and foremost, no fossil fuel usage. As we've seen on that slide, now I see 2030 dead cutoff, no more furnaces. Can be powered with rooftop solar. Yes, and then we can run off DC from rooftop. However, we are going to recommend that you have a battery backup storage. Eliminate risk of gas leak. We all know how, well, especially in Southern California, we know how big that has been. No more gas leaks, operational cost savings, and gas again being phased out in municipalities. A lot of the equipment nowadays, especially the mini splits, the VRF, the indoor unit can be powered from the condensing unit. So there's no need to bring power up into your attic or wherever you're putting your fan coil, resulting in much easier installation.
Yeah, and when Bobby says VRF, variable refrigerant flow, he's talking about what you saw in the video where your system ramps up and down like in an infinite way to
Yeah.
adjust the delivery of heating and cooling to the demand instead of just being a jet engine that's on or off.
Yeah, Nick, since we're talking on that subject, you're absolutely right. There's a couple different terms: variable refrigerant volume. Um, Basically, we're using is an inverter compressor, and that's different when Nick was talking about a fixed speed compressor, which it kicks on and off constantly. As soon as it meets the set point, it goes off. And then you have a compressor contactor pull in and it ramps up, it goes 100%. That's the old style condensing unit. What we're talking now is if you, let's say you live in 3 REN territory and it's not extremely hot, it's more like a accelerator on a car. So if you could see your accelerator going up, if you want 87 degrees or 76 or 64 as your set point, it's just going to ramp up and down to that set point, just like an accelerator in a car. So it's much more efficient. We call it an inverter. You can call it a VFD driven compressor, but it's all the same. It's a variable speed compressor. So we're getting much better energy efficiency, and it's a better way to air conditioning and heat. So
yeah, and in Title 24 we call that variable capacity heat pump, or VCHP.
Yeah, we'll do a deeper dive into VCHP because it's a very important term that's coming. Okay, so achieving both heating and air conditioning with one system. Again, this is just a reversing valve. So there's a lot of talk about apartments and condos and any type of rental needing to have or should be having air conditioning. Now it's so hot in the summertime that in places it wasn't very hot. They're going to have to use a heat pump for that. So if that ever happens, where every apartment and every condo and every rental is going to get cooling too, it's all going to be changed over to a heat pump.
Right, because all the code really requires right now is heating, right?
Yeah, and this is kind of this is coming up, rising up again and again and again. And it's not passed yet, but it could definitely pass. Easier to install than an ultra low NOx furnace. That's an understatement. We're talking about a DX fan coil that looks like a furnace style fan coil. It can be upflow, side flow, but a lot of the low NOx furnaces are larger than the regular furnaces are. So you might need to do some construction either to get it up into your attic, or if it's in your garage, or if it's inside of your house. There's also different flue options that can be pretty difficult. So much easier to install than an ultra low NOx furnace. And next, Nick.
Yeah, and just to clarify, ultra low NOx is required what in the AQMD territories, Bay Area, South Coast?
Yep. Basically all the way down to San Diego, I think, is the only one left.
Okay.
Yeah. And then no exhaust to deal with. Again, going back to the top, elimination of fossil fuels, no gas leaks. With no gas, have no exhaust to burn off. And ultimately, why we're here is to help California meet its climate goals, which other states follow. Okay, so if there's one takeaway, at least from my portion, it's going to be variable capacity heat pump, VCHP. So if you were to write down anything, this is being recorded. This is a terminology that is used by the California Energy Commission. Variable capacity heat pumps modulate heating and cooling to match load, like we talked about earlier, about an accelerator in a car. Now, your territory is not the same territory as Palm Desert, for instance, that has a design condition of 122. So they're going to have different loads to meet, whereas you're going to have probably a much easier load to meet. So what these do, they modulate. Again, like an accelerator in a car, if you're not very hot outside and maybe your territory maxes out at 80 degrees, but you still want to have it 70 inside, it's not going to work as hard as it would in Palm Desert. Both the indoor units and outdoor units are quiet. I know that a lot of this 3REN territory is by the ocean. So a lot of times when we have setbacks by the ocean, the outdoor unit, they would prefer to have it around 55 dBs. We can get there with this type of equipment. It does have a longer lifespan than a traditional on-off type condenser, where even currently it's still out there, but what happens is the equipment will meet set point. For instance, it's at 72, it hits 70-ish, 72, and then it'll go off. That's the old style. And then it'll get 77 degrees below set point, then it'll kick back on, compressor contactor kicks on, and it does that the whole time it's on. It goes 100% of its capacity, very inefficient. So when we turn to these new type of equipment, which we call, again, VRF, VRV, inverter, VFD compressor, it can be as much as 60%. I know we showed on a previous slide 40, but I can tell you from the company that I represent, we go up to a 42 SEER unit. So the efficiency ratings really skyrocket when you're using this new type of technology. And Title 24 Part 6, VCHP has a compliance credit that's bigger than any other credit that I know that's offered. Nick, can you verify that? I mean, I know that was at one time, that was
No.
one of the biggest ones you can get.
If anything, that was strengthened this code cycle. Still huge compliance credit, and very few things are worth that much in Title 24 energy modeling.
Yep. And for those of you who know me or know Nick, we've had some jobs in the coastline where they have all west-facing windows, and they can't meet the compliance credit, and they're looking at us like, we need to change this whole thing to variable capacity heat pumps. We need that credit. So it's a very important part of what we're trying to push with heat pumps. So variable capacity heat pump credit, you will hear more and more about that. And soon the CEC will extend the heat pump credits to allow more ducted systems to be used. Right now it favors ductless, just because we'll talk about that later. There's about a 30% reduction using ductless, but soon to be added is going to be more of the ducted units.
Yeah. Could you address Jurgen's question in the chat? It's important, I think, that we address these VCHP, the various acronyms we've thrown out, are the best in class heat pumps. There's also a different class of standard heat pumps that are more on-off style.
Yeah, I'm just looking through it now. Nobody outside the circle uses the, yes, you're right. Those acronyms, well, VRF is an acronym that has been used for the last 5 to 8 years. A VRV is another manufacturer. It's the exact same thing. And then inverter is, you can see that even on, if you go to Best Buy and microwaves are using inverters instead of straight, basically what we're using to run the compressor. So a lot of these acronyms have been around for a while. VCHP is pretty much new to the code cycle of 2022. So in the world
2019, yeah.
2019. I'm sorry, I'm just looking at this.
Yeah.
So in the world of Title 24, that is relatively new, but we are seeing it more and more. And it's at this point, Nick, it's strictly California using this acronym.
Yeah.
Is that
just
for Title 24? Yep.
Yeah.
So you are correct.
Thanks, Bobby. Yeah, just wanted to clarify that you can electrify your home with a simple heat pump. So it doesn't have to be these best-in-class inverter-driven compressors, but that is the best practice, and what we're going to recommend for you if your budget can handle it. All right. We wanted to spend most of our time talking about these common impediments to adopting heat pumps, or at least things that are cited as obstacles. Ductwork, air filtration, various configurations that are a little more complex, I think more feature rich, but wanted to cover that. This myth that heat pumps don't work in cold weather, as if we have much cold weather here that would challenge a heat pump, sizing, and panel upgrades. But first, let's go back to your Slido control panel. And let's ask you what challenges you encounter retrofitting to heat pumps, not new construction, but you've got an existing home. You want to consider using a heat pump instead of a gas furnace split system. What challenges do you run into? Bobby, how about you? What are the ones you hear from customers most?
I think one of which is when they are using a furnace and they don't have air conditioning, so there's no condenser, that the panel upgrade to accept the power for the condensing unit has been one of the challenges, as well as can we use the existing ductwork.
Okay.
But I think we're going to address that pretty soon here. I've
are.
talked to quite a few electricians at my own house, and I just had a 220 put in for a jacuzzi. They're just saying, everybody's going to have to do these upgrades. I mean, it's just going to have to happen.
Yeah,
you're
like
going to
future-proofing your house for solar and
so,
EVs
and load sharing and your car, jacuzzi, your dryer. There's a lot of different things that are going to be required. Okay, here we go. They're starting to fill in. There we are. There's doing the
ductwork.
Can we use the ductwork from the furnace? That's a big question, especially if it's old and it's leaking more than 10%. Will it pass? Those kind of things.
Right.
And then the first cost, which we're going to address, these are almost a lot of the topics and the challenges that we've learned from our focus groups, and we're going to address today. So those are really good ones.
Agree. All right, let's start with ductwork. And we heard this time and time again in focus groups. When we have our ductwork in unconditioned space, picture here is showing it in a crawl space, probably more commonly done in California up in an attic. It's exposed to more extreme temperatures. And so leakage can account for 25 to 40% of the energy used for heating and cooling. That's money you paid for that's being wasted. I think this was an NC State study that found that. So best practice is move those ducts into conditioned space where leakage is irrelevant, almost, and your system can operate far more efficiently. The ductwork in unconditioned space adds to the capacity requirement of your system because you have to account for losses up there in unconditioned space. So you may also be able to install a smaller system with ducts in conditioned space. But what if you can't move the system into conditioned space, can't do the best practice, and you're stuck with existing ductwork? Well, the Title 24 code provides a useful reference point, 10% duct leakage. When you have more than 10% duct leakage, your system's operating less efficiently, you've got higher energy costs, your system's working harder and longer, means it won't last as long, and it's very difficult to size your CFM, your airflow into each register, into each room, because you can't really predict where that energy is leaking. All kinds of problems. And Title 24 now in 2022 has set this 10% duct leakage target for altered duct systems where you're adding more than 25 feet or where you're altering the HVAC system itself. The code says you need to achieve 10% duct leakage or less, or 7% to outside, just a different test method. And if you're unable to meet that 10% goal, you need to go through every single visible, accessible part of the ductwork using smoke and other tools and seal every accessible leak. which is considerably involved and costly and complicated. So to me, that 10% goal provides a useful decision point. If you feel an existing duct system, you're able to get to that 10% goal, okay, that might be worth keeping. Might be worth those cost savings to the homeowner. You've got a reasonably performing duct system. If you feel, or you test it, and you're well above that 10% goal, it might be worth recommending to that homeowner that the ductwork be entirely replaced. So back to Slido now, for those of you in the business, what % of the time do you see your projects reusing the existing ductwork?
Yeah, if hopefully most of you are joining Slido, this is important for us to understand as well. This seems to be one of the major topics of, do you really want to do this or not? Or if we have to replace all the ductwork, is it really worth the time and the effort and the money? So
yeah,
I mean, so far it looks like I don't know how many people participated in the 50/70, but
yeah, most of
I
the
would
times
say
we've
that's,
taught this course,
yeah.
it's this is the dominant answer, or over 75%'s been the dominant answer.
Yeah.
Okay.
Yeah, Ted Tiles just brought up two important points, one of which you just addressed, Nick, was, if you're replacing ductwork and it's, you have a leaky duct system that somebody else put in, if you can't fix it, you got to replace it. And then duct sizing also is going to be another issue you'll have to deal with. I mean, the airflow percentage, are they close?
Yeah, well, you want to assume that the prior HVAC contractor, when they designed the duct system and designed it to be compatible with the HVAC system, the air handler, got it about right. But that isn't a safe assumption, is it?
No,
And
especially with now, our new code requires that we, on the ducted system, have 350 CFM per ton at the return. And I want to stress at the return, because that's more like 400 CFM per ton. So if the duct system, that's what you're going to get from new equipment coming out of manufacturers now. So if it's close to that, you should probably be okay. So that's kind of the number where we're going after, is going to be somewhere in the 300 to 400 CFM per ton for the ducts
yeah,
to be balanced.
and the best practice we always recommend is hiring someone who has the experience and knowledge to do the ACA manual calculations, manual J, manual D, manual S, to make sure the right amount of heating and cooling gets into each room, the ducts are sized right, and the capacity of the system's correct. Reasons to retain existing ductwork, the obvious ones: cost and complexity and time. So let's keep moving. Here's one that Bobby was hinting at. There are also energy code requirements when you're doing a altered HVAC system or a new one, that forced air systems have a certain efficiency at moving air. And the heat pumps get a slightly easier road here with the 0.58 watts per CFM target. All gas furnace air handlers have to meet 0.45 watts per CFM. So that's, I think, was put in place to give us a small nudge towards heat pumps. But this means your ducts need to be well designed, doesn't it? Because you need to show that your fan's pulling no more than 0.58 watts for every CFM it's moving. And if you have a poorly designed distribution system, you're liable not to meet this, and then have to make major changes to that distribution system to get back under that number. And here's the 350 CFM per ton. So we put these Title 24 requirements up here just so you're aware that when you're making retrofits of HVAC systems, there are a number of HERS verified requirements that might nudge you towards a new replacement duct system, might nudge you towards a ductless system. Just wanted to make you aware of all that. Here's another one. The 2019 code for the first time upped the requirement on return air filtration to MERV 13 for all ducted systems, including retrofit. MERV 13 is a standard that signifies to what extent that filter is going to remove common pollutants, allergens in the indoor space. And this was an increase from MERV 6 or MERV 8, so it was a significant jump. The reason the state made this mandatory was we don't have healthy outdoor air. So our best chance at improving indoor air quality and health outcomes is to better scrub the indoor air by putting in a very cost-effective MERV 13 filter. But what it means is there's more pressure drop across a MERV 13 filter. There's more resistance to airflow than there was to the MERV 6 or MERV 8. So you're likely in a retrofit situation to need to upgrade that return grill, even potentially add an additional return grill to spread out that resistance on multiple filters. So here's another reason for you to consider modifying that distribution system, because you're going to be required to put this MERV 13 filter in it. Obviously, ductless systems avoid this requirement. Ductless systems have a fan built into the indoor fan coil, and because they run so much, they tend to do a good job of filtration. They're purring along there at low load a lot of the time. I'd encourage you to use this not as an obstacle to HVAC installation or something to grouse about. A selling point. You can now show that as part of your HVAC services, you have the potential of improved health for that family because the MERV 13 return filter is now pulling out smog pollutants, allergens, bacteria, and virus, especially coming out of COVID, right? Something every homeowner should be find really valuable. That PM 2.5, that's diesel emissions, and we have a real issue with that statewide. Also, your HVAC system is required to have, as I said, enough return grill square inches to spread out that pressure drop to make the MERV 13 filter effective and meet your 350 CFM per ton target, meet your watt draw. And this is a useful table, not required to be met, but a nice, simpler pathway to avoid the fan watt draw test if you design your returns to fit this table. And notice that at 3 tons, this table recommends 2 return ducts, 2 return grills. Bobby, why don't you talk to us next about the various configuration options with these heat pumps?
Sure. I want to put you on the spot in a sec, Nick.
I'm ready.
So on the left-hand side, you're going to see a colleague that Nick and I used to work with, and this is a new installation in her home, which is a ducted mini split system or ducted split system. And you can see there's a air filtration system right in the middle of the picture on the left. And then that's basically a ducted direct expansion system. On the right-hand side, Nick, if you want to show your new installation, now would be the time.
Oh, okay.
Yeah. I mean, because we could show it as a vertical. And Nick, you want to talk about this slide real quick?
Yeah, I just accomplished my own home electrification goal. And the furnace in the upper left of this picture is what my attic used to have up there. You can see I was not following best practices. I had the air handler up in the attic. I had ductwork in the attic. That is an unconditioned, non-high performance attic. And I'm in a similar climate zone to many of you in the Central Coast. I'm in Long Beach, climate zone 6. But the most practical, readily available, readily installable, lowest cost conversion to a heat pump for me was taking down that furnace and putting in its place a similar size unit that could interface with the existing ductwork system. And we did have, buried ducts up there in the attic. So that's what we chose to do. Best practice would have been to go with a ductless system, but we're not made of money, and it got installed. I think I've got another picture here showing, the indoor and outdoor unit for the 3-ton system that we just got installed, and it's working great, purring along. And I called the gas company to remove their meter yesterday, so that was a good.
Oh, that must have been a great moment for you.
Yeah.
Great. Okay. So we have, just like Nick's new unit on the left-hand side, ducted. The one on the left picture is more like one you're going to have in your closet or in your garage. And then the right-hand side is something that's true to my heart, is going to be the ductless systems. So you have many different varieties. You have floor-mounted units. You have high walls, which is the world's most commonly used form of air conditioning residentially, if you didn't know that. And then we have our cassette units as well. And there's other variations of ductless units. But one thing I want to mention is, like in Nick's application, he has a mini split ducted system. So there's some confusion over ductless and ducted, but you can get both matched to the condensing unit. So the next slide is going to be Rick Chitwood. So if you don't know who Rick is, he's a legend in the code era of Title 24, responsible for VCHP. We just saw in the chat, many people didn't even know what that was, but you will know what that is. It's a variable capacity heat pump. He's from Shasta, California, and all the advancements, including ducts and conditioned space, fan water, there's just too much to list. But some of the 10 advantages of ducted mini splits, according to Rick, one of which is size. If you look at the picture, the height of that unit is a little bit smaller than Rick's head. So it's right around 10 inches. So that can fit in a lot of tight spaces. Very high AHR equipment performance ratings for these ducted units. Also, oftentimes you can put the ducts and air handlers in conditioned space. For instance, you could be in a master closet and drop the closet, and you can have your ducts running from there. Or you don't even need ducts. You could just duct straight into the next room. And then you're going to meet the duct in conditioned space as well as the equipment. High comfort levels. We mentioned earlier about the inverter compressor ramping, or the VFD-driven compressor, like an accelerator ramping up to meet set point and humidity. These also have great air filtration, particle removal. In a lot of cases, these are made for California. I can say that is the case of the equipment that I represent, that we do and adapt all of our ducted units to MERV 13 filtration so they can handle the static. Conventional appearance, these are not meant to be seen. So you can have nice slot diffuser. You can put these in some cases under the home or in the attic. You won't get the conditioned space credit, but they can go there. Low operating costs. As I mentioned earlier, these mini splits can go up to 42 SEER 1, and very, very low operating costs to run these systems. And as far as maintenance, you're just cleaning the filters periodically, depending on how much you use it. And then you will have an occasional coil cleaning depending on how clean your filters are. So that's about it. Also, what the last bullet point is, built-in fault detection. You can put things like, give me a code after the units ran 200 hours, so I know to clean the filter. It will tell you if there's an issue. For instance, if it's low on gas, it'll give you a signal that it's low on head pressure. So you know to call your service provider and come out and you have an issue with perhaps the gas being leaked out or something like that.
Refrigerant, you mean?
Refrigerant, yes.
Yeah.
Refrigerant. So this slide I really like. This is almost like the slide that from the video and the illustration of how the heat pump works. This does remind me of an application. I know Nick likes this example that in Seal Beach, California, there was 3,000 units in a retirement home. And some of the advantage Edison was an energy provider at the time, and they had radiant heat inside of the wall and the ceilings. It used a lot of power. It was all electric, and it took about 2 to 3 hours to warm up the room. They opted to go this direction, and this is close to 20 years ago. And a lot of the advantages I'm going to mention now are some of the reasons. One, there's no ductwork. You don't have your 30% duct loss running from your furnace to your furthest diffuser. There is no MERV 13 filter requirement. There is also no fan watt draw requirement because you have no MERV 13 filter. It does comply with Title 24 variable capacity heat pump credit. That's 10%. That's larger than anything you can get. This is important because I want everybody to know, like in the Seal Beach application, every bungalow had its own unit. There was no return shared air duct like you were going to find in retirement homes where you might have a common return and everybody gets it. Thus, everybody in the time of COVID got all the same air. They're all breathing the exact same air. In this application, everybody has their own unit, their own return air. They're not sharing any air with anybody else. So this was an application that I paid really close attention to because there are so many care facilities for the elderly that were getting hammered by COVID, and there was just no other way to get it under control. And we're watching this place in Seal Beach, and there's no breakout. So the compartmentalization of the indoor air quality was the reason. So to me, that's a huge benefit. Also, zone control. Everybody will have their own thermostat, set points, and efficiencies. So you can turn it up and you can turn it down. There's some technologies where you can have one in heating and one in cooling. So there's a lot of great opportunity and options. Easier to have the equipment in conditioned space. You're going to get all the credit using a ductless system. No MERV 13, no fan watt draw, Title 24 compliancy, and you get the equipment in conditioned space credit. So as far as that goes, you're going to get it all. Easy installation. Back to our comments earlier about the penetration, about the size of a tennis ball. In this case, it's not red and blue, it's just white, but yeah, that's the case. Tennis ball penetration up by the air handling unit, that's your only way in, and that's it. You have a condensate drain, no mold growth. So because you don't have your ducts running through your spider webs of duct running through your attic or under your crawl space, there's no mold growth opportunities for that. So if you think about, just this summer, we run our air conditioning, it's humid, it's getting wet inside of there, and then we shut it off. And then September, say, and then it just sits there until heating season comes. So you get a lot of bad things growing in there. Nick mentioned earlier, and I'm being a little redundant, but capacity loss, 30% on average is your capacity loss. Even if you have no ductwork leakage, if you have your air handler or your furnace in your garage and your second story is your furthest room from the garage to that room, you have capacity loss. It's going to lose energy. So in these cases, you don't have any capacity loss and maximum energy savings. Again, in this application, there's equipment that can run up to in the 40 SEER range, super energy efficient. So many, many advantages, especially to code for ductless systems.
I use these in my ADU that I just built, and they allow for vaulting ceilings really nicely too, because you don't have to save that attic space for your mechanical systems anymore.
Yeah, Nick, I just went on a couple, ADU applications, and it seems like ductless mini splits, like I said, 30 years ago, almost 100% of the population of the U.S. didn't even know what that is. now it seems like every ADU I'm going into, or even modular homes being built and transported, are getting mini splits.
Yeah,
Because
perfect.
compliancy wise, they're set. They really
Yeah.
don't have anything to deal with. So
Yeah.
a really great option. But
And simplest system, no ducts. Yeah, important to mention though, you do need to dispose of condensate with
yeah,
these
but
indoor units. Yeah,
yeah, in this application here, it's kind of a perfect world application where you can take your condensation and water a plant. But if this is an
right.
indoor air handler, inside wall, you're going to have to find a way to either pump it, which we don't suggest, or vertically feed the condensation into a drain, which we do suggest. So condensation is definitely one of the big application issues you want to consider.
Yeah.
This is something that's we're going to recommend that you go see your distributor for whatever equipment that you like to purchase. At least the distributors I know, the larger distributors do not have any equipment that does not meet any of these SEER ratings, so you don't have to worry about it. But if you ever consider potentially buying a piece of equipment online, or maybe it's even overseas, there's a good chance that they may not meet the federal minimum requirements for 2023, and you're not supposed to be, they're not even legal. So I suggest you go and talk to your distributors. Basically, it's 1 point more. So if you see the split systems, heat pumps, current is 14 SEER, the new M series is going to be 15 SEER, and the new M1 rating SEER 2 is going to be 14.3. It sounds complicated, but it's about a SEER point higher for us in California. And again, just your distributor will know. And I am sure that most of them have replenished their anything below 14 SEER. I know on behalf of the distributor that I work with, we do not sell any 14 SEER product heat pumps at all.
Yeah. Ted's asking about Energy Star qualification and that might be required for IRA tax credits.
Yes. So Energy Star, it depends on the tax credit. For the Inflation Reduction Act, that's a federal tax credit, and I believe it has to meet a certain SEER 2 requirement. But a lot of tax credits outside of the Inflation Reduction Act will require Energy Star. There is a couple different websites that have this information, but your distributor should have that for you. They will go, okay, these meet this criteria, and this is the one we expect you to use. Energy Star does qualify for certain rebates that some non-Energy Star equipment does not.
Doesn't seem like a high hurdle, is it, Bobby?
Now, a lot of this equipment's already up there,
Yeah.
but there are, for whatever reason, the 18,000 BTU range is tough for manufacturers to get to. I'm not exactly sure what that struggle is for Energy Star.
Okay.
It's more on the HSPF side of that. But yeah, you are correct. The ducted systems, I know that we have ducted systems that do qualify, but they definitely have a different output, and they're almost all the high efficiency high walls will qualify. But yeah, you're going to want to check the ducted systems.
Okay, thanks for that, Ted.
Yeah.
Yeah, for those of you who aren't HVAC experts, SEER is the cooling efficiency rating, as is EAR, just measured in a slightly different way, and HSPF is the heating efficiency rating.
Yeah. Okay, I'm going to go ahead and give this back to Nick. This is a 3-REN example, and I'll just hand it over to you.
Okay. Yeah, we found this house on Zillow or Redfin somewhere. We wanted to make it as real world as possible in Santa Maria. They shouldn't have a lush lawn like this, should they, Sarah? But they do. 3-bed, 2-bath, 2,100 square feet. And we chose that because that's the size of one of our prototype energy models. And we thought, perfect. So we thought, let's use this as a case study. Let's say the current split system, gas furnace, air conditioner is at the end of its useful life. And let's consider various like for like replacement and heat pump replacement options.
Hey, Nick, did I hand that over too early? Am I supposed to?
Yeah, I think this
Yeah,
was.
I think I'm still supposed to be going. All right,
Take
sorry
it back.
about that. Yeah,
Yeah.
I'm taking it back. It's all mine.
When we
Okay.
get to the economics, I'll cover
Yeah.
it.
Okay, thank you. Considerations for like. This is what you're going to be walking into most of the time. You're going to have a like for like system. If they have an air conditioner, if it's in Santa Maria, likely they're going to need one. First bullet point, we've been talking about this 30% capacity loss. Second bullet point, ultra low NOx furnace required, add $350. Well, I can tell you that might go up from there. That's going to be a minimum of $350 for the equipment increase. For the low NOx furnace versus just a regular furnace, but the installation is going to, it could be much more than that. Not much more, but it will be more. MERV 13 required. And then a HERS rater. You're going to have somebody come on and test out your leakage. And that's going to be required as well as potential mold buildup. Or the second system is going to be a single stage central heat pump. We're going to go with the 14 SEER. I know that the SEER 2, we have to go higher, but in this example, we're going to go 14 SEER. Again, we have a lot of the same. Duct loss 30%, MERV 13, HERS rating, mold. Comparable costs to a gas split system. So putting it, but here we are up to, because you're not using gas, like the unit to the left, we're going to have up to a 24% greenhouse gas reduction. So that's very big. And then we're going to go towards the deducted mini split. This is what Nick put in his home, which 17 SEER, 30% capacity loss again, up to a lot of this MERV 13, HERS rating, potential mold buildup, great overall efficiency, and up to a 37% greenhouse gas reduction. And then we go to the ductless unit. And we just took a 22 SEER unit. We could have easily gone for a much higher SEER unit, which are out there. But we, the range for the mid-price ductless unit is around 22 SEER. So in this case, the 30% capacity loss is gone. So that's right off the bat. And we don't even calculate that number into a lot of our savings. That's just happens automatically not having ductwork. No MERV 13 requirement. So that's gone. Since there's no ductwork, there's nothing for a HERS rater to do there. So that's gone. There's no mold buildup in the ductwork, and you're going to get your best efficiency using ductless units. Again, you have no wasted energy going through ductwork. And this one, you're going to get 37% greenhouse gas reduction. Just due to the fact that you're not using gas. And this is what we do every single day. Our company does this. We do design work. We work with companies like Nick to try to make sure we're compliant. But do they ducted and ductless units work? Almost every job we have a combination. On the right-hand side, you're going to see a cassette style with a 67-degree set point. In the middle of the home where the hallway is, you're going to see a high wall unit with a 68-degree set point. And then the top, you're going to have another ducted system that's going to be servicing that. We have a 70-degree set point. And then on the bottom, you're going to have another 69. That's supposed to be inside the house, another cassette style unit. So can they work together all the time? And then this kind of is a segue because it looks like we're using this slide. And then to me, it looks like wintertime outside. So we are going to get into some cold climate applications. But first, we want to, if anybody's listening to my last slide, hopefully you have some advantage of the ductless systems that appeal to you. Please feel free to give your comments here of any advantages of the ductless system. I could bring them up again. Oh, here we go.
And Jürgen's right. If you're doing the VCHP compliance credit, you're going to need a HERS rater to verify that as well.
Ah,
You don't get completely out of HERS verifications with the ductless systems.
I like that. Could vault the ceiling.
Yeah.
You know, we've done quite a few applications where we've had like a A-frame church type setting where we'll just line up high walls along the side of the wall or a floor mounted unit.
Mm.
Zones is really, I mean, that's back to the application in Seal Beach. You know, you have a high wall with yourself in there or your significant other, you are not sharing a return air with anybody else. So, you know, health wise, that's very important.
Right.
Lower cost, yes. Back to the tennis ball example. You know, you're running 2 refrigerant pipes, saturated vapor line and suction line through, and then that's it.
Yeah. Although to
Great.
Jurgen's earlier point, when you get to 4 or 5 indoor units, you're probably going to be higher cost with a ductless system than ducted. Right?
Yeah. Mm-hmm.
Yeah.
Yeah. You know what? One area that's probably 10 years ahead of where we're at here in the US is going to be Hawaii. There's no need for heat in Hawaii. So literally there's no gas lines ran anyway. But these units have been installed in Hawaii for a long time. And the most common unit is going to be the high wall unit. And again, yes, you're gonna run into, if you have 4 air handlers, you're gonna have 4 condensate lines, and then you're going to have 4 refrigerant lines. So yeah, you're gonna have more equipment going in. You're gonna have more copper going in. You're gonna have more condensate to deal with. But on the other hand, you don't have any filtration and all the stuff you're dealing with, the HERS rating, the MERV 13, the fan watt draw is all gone.
Simplified.
Yep.
Now we've got ducted up on the screen. So if you can answer that too.
And sorry to interrupt, but just wanted to give a time check. We have just about 15 minutes left.
Oh,
Yeah.
okay. Wow. Sorry, Nick.
Yeah.
Cleaner install. I'm going to just jump. A lot of times, if you have ducted systems, and I'm going to do this, Nick did it too, and you want to change over, if your ductwork is there, you know, you could likely use it, and then you don't have to put multiple indoor units. Cold weather performance, I'm just going to touch on this briefly, that in cold weather climates, before inverters, when I started, there was non-inverter mini splits, and they did not work if it was 30 degrees or below. They just stopped heating. Now that we have inverter drives, and I know the terminology is getting confusing, but the inverter drives, whatever you want to call them, VCHP, VRF, mini splits, most all manufacturers do have cold weather units. And what we do is, since the compressor never stops, it continues to run. It flashes refrigerant into the compressor so it doesn't overheat, and it actually can spin bigger than its capacity. So we can go into very cold climates. And so, Nick, I'm going to go ahead and slide you over to the next slide so I give you some time to finish. This is a mini split, very good capacity heat pump mini split. If you look on the left-hand side, the heating capacity is almost 100% at 0 degrees Fahrenheit. And that's the takeaway. You can use this unit in California climates. You can use it in Yosemite. You can use it pretty much anywhere, as long as it doesn't get past, let's say, minus 13 degrees. So this is going to be applicable now that it's not your grandfather's heat pump anymore. The new heat pumps can operate in extreme weathers. But what we do see in California is that we do see 113 degrees. You know, we see that in Palm Desert. We see that in Arizona down to 122 degrees. Back then, condensers didn't even work at that temperature. Now you're getting 83% of capacity. So if you're designing at 122 degrees, you're going to have to bump up that capacity so it meets it at 83. So the takeaway, we can meet extreme weather performance with heat pumps now.
Yeah. Like most myths that seem to persist, there was some basis in truth in the past, right, Bobby, about cold weather performance. but that's been worked out.
Yep, and this is an example. This is a coworker of mine. His name is Dwayne. This is his house, and this is an air handler, just one of off-the-shelf air handler, nothing special. It's 28 degrees, and it's set point, and then it's delivering 122 degrees off the air handler. So it's performing, and they can produce that type of output. One thing about sizing, especially California, bigger does not equal better. We've seen this in the past where the major impact is going to be oversight. When you size the equipment too big, it's going to come on and off too fast. It's going to meet set point, it's going to back off, it's going to meet set point, it's going to back off. Your humidity levels are going to bounce all over the place. Your equipment wear, your condenser will die if you oversize it greatly, and diminish noise and comfort. So you want to make sure that you do all your calculations correct and you size the equipment correctly. And your distributor of your equipment will be more than willing to help you with that. So with that, Nick, I think now I can hand it over to you.
So yeah,
yeah.
Don't size your HVAC system by rules of thumb. Don't size your heat pump system by what the furnace used to deliver in terms of heating. It's probably far oversized. And start by reducing load first with insulation and windows, like Sarah just did. Consider enhanced air leakage testing, etc. And then perform load calcs to really get it right. So one of the last hurdle we wanted to cover was panel sizing. And as Bobby said, the biggest hurdle is when you don't have cooling and you need to find room in the panel to add a heat pump because the furnace used to not require any electricity. But if you already have cooling installed, you have the capacity for a heat pump. This is not an increase. It's a lateral move, right? Because you're still providing cooling and now you're just providing heating, but with the exact same energy use. It's also really convenient that with variable capacity equipment, power goes to the outdoor unit and then the refrigerant lines and power lines go to the indoor units. So I was able to free up a 120 volt circuit for my old air handler in the attic that I don't need anymore, as an example. And we need to anticipate that we need to future-proof our houses at this point. And so if you are in that situation where you're right at the edge of your panel space and you need to add heating and cooling with the electricity panel, well, you might think of that more as a future proofing for EV charging and future solar panels and the other electric loads you're likely to need that we haven't invented yet. Don't blame it on the heat pump is the bottom line there. But there are circuit sharing devices like that shown on the right there that I think, Bobby, one of your employees recently installed between his dryer and his EV charger.
Yeah, so Jay's he's actually on the line, but he doesn't have the ability to
Okay.
But I can mention it. So Jay a year ago he bought a Tesla or almost 2 years now, and he only had enough. He needed 220, and he also had a 220 dryer that was already had its own circuit, and he was able to circuit share. Whenever the dryer came on, it just basically kicked off the gas, or kicked gas. It kicked off the 220 going to the car, and when it goes off after an hour, the car comes back on. Yeah. So circuit sharing, I could really see as a big benefit, especially if you don't have the power and you need to run two different 220s at the same time off the same circuit.
Wanted to make them aware of that. Also wanted to make them aware of the Watt Diet tool, which can help you sort of weigh in with your electrician on, do I have enough panel load? Because it takes you through the NEC load calcs that your electrician should be doing with your panel. And you can do some what if analysis on various heat pumps and see if you can fit it in under the wire. Now, we probably should have started with economics because it's what tends to make the decision. I'm going to skip your preconception and go to this case study. Remember the Santa Maria house? Well, we looked at first cost and utility costs, so basically total costs over 15 years for a like-for-like replacement, and those 3 heat pump scenarios Bobby did for you. And, you know, the like-for-like replacement cost about $8,500. The annual utility bills, $2,500. That's gas and electricity. That assumes a gas water heater. So they have roughly $45,000 in utility costs to run that house for 15 years. A dumb heat pump, a central heat pump, similar costs, but qualifies for almost $5,000 in incentives today between the tech program, the federal tax credits, and 3C Ren's energy savings program, which, check that out. The incentives go to the contractors, so you need to work with your contractor to make those come to you. But if you're a non-hard to reach customer saving 100 therms per year, that came out to $2,000. So that's the incentive we use for all the heat pump scenarios. The utility bills went slightly up for the dumb heat pump, but with the incentives, it was an $800 benefit over 15 years to the homeowner because of those incentives. The ducted mini split, though, utility bills come in under the baseline, the like-for-like replacement. So they're $2,000 to the good. Same with the ductless mini split, even though the ductless mini split costs $5,000 more to install for this whole home, and doesn't qualify for additional incentives, the utility bill savings, you know, made it just about as good as the ducted scenario. So Santa Maria has very little heating load in the energy modeling software. Those numbers are going to be even better if you're inland, more Paso, more extreme climate. And this bears out that there are significant utility cost savings with heat pump retrofits, not necessarily the central heat pump, but the best in class equipment. And with today's incentives that have never been better, now's the time to consider this advanced variable capacity equipment done in conditioned space if you can, because we find savings in San Francisco, in Walnut Creek, and throughout 3C Ren territory. Wanted to cover incentives too in a little bit more detail. Energy Smart Homes has an all-electric retrofit program and an all-electric new program, so check that out. Tech has $1,000 rebates to the contractor, with a larger one coming for the water heater. And 3C Ren with their energy saving program. When I put together these slides, first time I'd seen that, wow, that's a well-designed program with some significant savings. And the federal tax credit, what we used to get on solar, now extended to heat pumps and heat pump water heaters. And these all stack on top of each other in most cases. Not to mention this IRA HERE program that can be $14,000 for a low-income customer. So I don't know, Sarah, do you want to sum things up, or do you want to let people do these final Slidos?
Yeah, if we could just skip ahead just a few slides, I can run through my closing and then we can open it up for questions.
Okay. So we covered the value proposition. We covered some of those key installation hurdles, covered how they work. So hopefully we advanced your understanding. There's our contact information. And let me hand it back to Sarah.
Yeah, thank you. So just in closing, I wanted to highlight 3C Ren has a programs and incentives tool that gives you personalized programs and incentives. I added a direct link into the chat. So you can go through, select, or answer a few questions, and it'll provide not just 3C Ren programs, but just other heat pump opportunities, EV. It just kind of lists a bunch of variety of incentives in our area. And then in just kind of buttoning things up, we have continuing education units for both AIA and ICC. We have, we'll be sending out the slides and recording. And then there's just a few upcoming courses that I've listed. This is not a complete list. There's a lot more on our calendar. So, there's a lot of different opportunities. And I will just also launch our poll. This is just our general meeting usefulness. It just kind of helps us gauge future opportunities and just be able to bring more courses for you all. So with that, I can give it back to Nick and open it up for questions.
Great. And
Hey, Nick, I'm going to kind of
people
run
if you
through
want.
some of the chats. There's a couple.
Okay.
There was a question earlier about multiple indoor units and the complications, and it's there. Depending on the manufacturer, multi-zone mini splits typically go up to 2 to 5 zones. If you use a mini VRF, which are capped out at 5-ton condensing units, that can go up to roughly 9 zones. So you can, the answer to the question, you can run multiple indoor units from one outdoor unit. There was a good point with mini splits. Yes, you do. Still, unfortunately, to meet code, you have to have a PERS rater to check your refrigerant verification. I think Jurgen said there was kind of a red tape thing that was unnecessary, but you're right. And then the tax and rebates incentives, yes, you're going to want to make sure that the homeowner qualifies for that, because there is the biggest hurdle is going to be your medium income qualification that Nick put up there, where I think it was 91,000 for the household. That's going to be a hurdle to get around, but there are plenty of other incentives out there outside of that that people can qualify for.
Yeah, more than ever.
Yeah, there's a lot. So let's see.
I might have to debate Jurgen offline about his economic post there, because my modeling really shows that the biggest cost savings available for electrifying your home are in this area of HVAC. Water heating tends to be a push. Appliances tend to be a push, but there is significant savings available with these 3.5 COP advanced heat pumps done right compared to gas systems.
Mm-hmm. Okay, so it looks like Jurgen has an oversized heat pump, radiant heat floor. Depending on the condenser, it might not matter if it's an inverter.
Yeah, I like that point, but variable capacity equipment can ramp down sometimes to 25 or 30% of its max capacity. And some installers take that as an excuse not to do their sizing calcs. Well, that you still need to do your sizing calcs. You need to make sure that that range can handle the variety of climate conditions that your house is going to experience. So do those calcs, do the extra step.
Yeah, to Nick's point, so we sell a lot of multi-zone units, especially the mini VRFs, where I mentioned earlier, you can put up to 9 indoor units. And you can run, to Nick's point, you can run 1 indoor unit and not run the other 8. However, it's a variable capacity heat pump, so the refrigerant has to go somewhere. So what happens is, a lot of times, depending on the manufacturer and the way they handle their refrigerant, they might have, it might not be on them, but they might have one valve cracked open on another air handler just to let the refrigerant through. So your maximum efficiency isn't reeling down to 25%. To Nick's point, you don't want to oversize everything and thinking you're going to be getting away with something, because you're not. It's just not going to be running as efficient, but it will run.
All right. Well, it's 11 o'clock, so we are at time. But just want to thank Nick and Bobby for a great presentation, and thank you all for joining us. Just a reminder, you'll be getting a copy of the slides and a recording in your email.
Thanks,
you,
Sarah.
Great opportunity.
We appreciate it.
Yeah, thank you all. Bye.
Okay, bye-bye.
Keep up the good work.